video we are doing stoichiometry, but I want us to cover the limiting reagent. So let us start by defining a limiting reactant. It is a reactant that is completely used up in a chemical reaction. Then the reactant that is not completely used up in a chemical reaction is said to be in excess. For example, we can have the reaction between magnesium plus oxygen. Then we form magnesium oxide. And let's balance our reaction too. If magnesium is reacted completely in the presence of oxygen, that means magnesium will be a limiting reactant and oxygen will be in excess. So when we are doing our stoichiometric calculations, we work with the reactant that is limited. So we are going to use number of moles of the limited reactant, which is magnesium, to determine the mass of the product that is going to be produced, or the number of moles of the product that is going to be produced. It is not proper to use the number of moles of an excess reactant because some of the moles are not going to react. So let us have an example. Example 1, methanol CH3OH, which is used as a fuel, can be obtained from reaction between carbon monoxide and hydrogen. Then we have our chemical reaction, CO plus H2 forming CH3OH, and the reaction is balanced, so it's okay. If 350 grams of carbon monoxide and 65 grams of H2 are mixed and allowed to react, determine the limiting reactant. B, determine mass of ethanol produced. C, calculate the mass of reactant in excess. So the first thing that we need to is to check the molar ratios of the reactant. 1 mole of carbon monoxide requires 2 moles of hydrogen to produce 1 mole of methanol. So our required ratio is 1:2. And this is carbon monoxide, then this is hydrogen. Let's not worry about the product because we are to determine the limiting reactant. Then let us see the available ratio, available molar ratios. So this means we need to calculate number of moles of carbon monoxide and number of moles of hydrogen. Let us start by number of moles of carbon monoxide. This is going to be mass over molar mass, and mass is given to be 350 grams divided by the molar mass of carbon monoxide. Carbon is 12 plus oxygen 16. This is going to give us 12,7 moles. Then let's determine the number of moles of hydrogen. It's mass over molar mass again. Our mass, which is 65 grams, over the molar mass of hydrogen is 2. We get 32,5. So these are the available moles. So on our available ratio, now we can say moles of carbon monoxide is 12,7 as to 32,5. Then we can simplify this ratio. As you can see here, we started by carbon monoxide in the form 1:2. So this one should be also 1:2 something. So meaning we need to divide by 12,7 both sides. This will be 1:2, 2,56. So now let us interpret this. Our required ratio, 1 mole of carbon monoxide requires 2 moles of hydrogen. But now 1 mole of carbon monoxide requires 2,56, which is more than what is required. So this means hydrogen is in excess and carbon monoxide will be the limiting reactant. So we can conclude that hydrogen is in excess, therefore carbon monoxide is the limiting reactant. If our final answer here after dividing by this was less than 2, that will be telling us that hydrogen will be limited because we'll be getting less than what is required. So we'll say hydrogen is our limiting reactant. But in this question, we found out that carbon monoxide is the one that is limiting and hydrogen is in excess. Let us go to the next question, B. Determine the mass of ethanol produced. So now to determine the mass of ethanol produced, we are going to work with number of moles of the limiting reactant, which we calculated to be carbon monoxide, which has 12,7 moles. Carbon monoxide and methanol are in the ratio 1:1. So meaning number of moles of methanol is equal to the number of moles of carbon monoxide, which is equal to 12,7 moles. But we want to calculate the mass. The formula for calculating mass, number of moles times is molar mass. Number of moles, which is 12,7. Then the molar mass of methanol is going to be carbon is 12 plus hydrogen is 1, then but there are 3. 1 times 3 we get 3 plus oxygen, which is 16 plus 1 hydrogen. This is going to give us 406,4 grams. let's go to C, calculate the mass of reactant in excess. To determine the mass of reactant in excess, we need to calculate the number of moles of hydrogen that is going to react with carbon monoxide. So I'm going to say number of moles of hydrogen reacting. This is equal to, hydrogen is in the ratio 1:2 with carbon monoxide. So meaning number of moles of hydrogen is twice number of moles of carbon monoxide. So that is going to be 2 times number of moles of carbon monoxide. Then this will be 2 times 12,7. And this gives us 25,4. They now want to calculate the number of moles in excess of hydrogen. This will be equal to the initial number of moles of hydrogen that we calculated to be 32 minus the number of moles of hydrogen that reacted. So this number of moles of hydrogen in excess, it's like leftovers. What is left after reacting? So it's initial minus the reacted ones. So our initial, which is going to be 32,5 minus 25,4. This is going to give us 7,1 moles. They now want to calculate the mass of hydrogen in these 7,1 moles. This is number of moles times the molar mass. Number of moles, which is 7,1 times the molar mass of hydrogen is 2. This is going to give us 14,2 grams.